All right, so first let's talk about integers. And an integer is a number. It's all the numbers we use to count with that can also be put on a number line. So 1, 2, 3, 4, 5. Not 1.5, 2.5, 3.5, just the counting numbers. 1, 2, 3, 4, 5, on and on to infinity. Okay, that's part of the integers. Also, 0 is an integer. And then all the numbers that are on the opposite side of 0 and the same distance from 0. So basically, the negative numbers. -1, -2, -3, -4. Now, of course, the negative numbers are not counting numbers. We don't tend to say I have -3 marbles, but the negative numbers are integers. So the counting numbers plus 0 plus all the opposites of the counting numbers. So if we break the integers down a little bit, I've already referred to the positive integers are the ones that are counting numbers. So the numbers we use to count marbles. I have 7 red marbles. That's a positive integer because I have a positive number of marbles. On the opposite side of 0, across the other way, these are called negative integers. Spelled with an A, not an I. So negative integers on the opposite side of 0 from the counting numbers are the positive integers, and we show that they're negative by putting a minus sign in front of each one to show where it resides on the number line. So there are different ways that we can compare numbers or integers. One is just by comparing whether one is bigger than the other. So if I have the integer 5, and I want to know whether the integer 2 is bigger or smaller than 5, well, if I put it on the number line, going 1 to 2, 3, 4, 5, on to infinity, I can see that 2 is smaller or less than 5 because it's to the left of 5. So numbers farther to the left on the number line are said to be smaller than numbers that are on the right to the number line. So any two numbers on the number line can be compared or ordered from smallest to greatest by putting them on the number line and listing them from the left to the right. Another way to compare is to look at how far a number is from the center of the number line, which is 0. So if I want to look at the number 6, I can say that the distance from 0 to 6 is 6 units. It means I had to walk 6 steps or 6 units to get there. 1, 2, 3, 4, 5, 6. So the value of the number 6 is considered 6 units. But notice that there is another number on the number line that is also 6 units away, and that's -6. -6 is exactly the same distance from 0 as +6 is. So we call this the distance from 0. We call this the absolute value. So we'd say the absolute value of 6, that's the math notation for absolute value, the absolute distance from 0 to the number 6 equals 6 units. The absolute distance from -6, so how far the absolute distance to go from 0 to the number -6 also happens to equal 6. So 6 and -6 compare as both from having the same distance from 0. A last way to compare numbers is what I did up here in the orange when I was setting up the definition of integers, is any number on the number line, any integer, excuse me, let's choose 3 in this case. The integer 3 has a value that is opposite, meaning it is the absolute distance from 0. 3 is 3 units from 0. -3 is also 3 units from 0, but they're opposite numbers to each other. So the opposite of 3 is -3, And the opposite of -3 is +3. So numbers that are absolute values of each other, or that have the same absolute value, have to be, if they're not the same number, have to be opposites in order to hold the same distance from 0. So let's do a couple of examples to make use of this new information. Suppose I were given a bunch of numbers, 3, 7, 2, -4, 5, -8, and 0. Oh, and let's go with -1. Suppose I'm given a list of numbers and I'm asked to put them in order from least to greatest. Well, the easiest way to do that is to go ahead and just put them on the number line, or create a number, or write the number line out. So I have 0, and I'm going to go from 0 to 1 to 2, 3, 4, 5, 6, 7, 8. And then in the opposite direction, I'm going to do the same thing. 1, 2, 3, 4, 5, 6, 7, 8, and these are all negatives because they're on the opposite side. So now all that's left to do is mark all of the numbers in our list. So 3 is in our list, 7 is in our list, 2, -4, 5, -8, 0, and -1. So to write these in order from least to greatest, I just start at the left-hand side and I write -8, -4, -1, 0, 2, 3, 5, and then 7. So this time let's use the number line to determine the absolute value of a couple numbers. So we want to find the absolute value of -8, and let's find the absolute value, or let's do something else. Let's do something a little bit tricky. Let's put these in order. So the absolute value of -8, absolute value of 6, absolute value of 0, absolute value of -3. Okay, that's enough. So again, 0. Well, the absolute value of -8. So how many steps did I have to take to get to -8? If I walked backward to -8, I will have gone 8 steps to get there. So the absolute value of -8 is +8. So I'm going to put that over here on the number line. The absolute value of 6, well, 6 on the number line is right here. And how many steps did I have to take to get to 6? 6. The absolute value of 0, how many steps did I have to take to get to 0? None. I started on 0. I didn't have to take any steps. And then -3 is, say, right here. How many steps did I have to take to get to -3? Well, 3. So you can see that all of my numbers, when I put them in order, would be 0, 3, 6, and 8. This is numbering my absolute values. So now I have to keep them in absolute value format. Absolute 0 is smaller than the absolute value of 3, which is smaller than the absolute value of 6, which is smaller than the absolute value of 8, because they all line up from left to right on the positive number line. So our next example, we want to find the opposite of -3 and the opposite of 5. So again, on the number line, since we're looking for opposites, let's look at where we started. I started at 5 and I started at -3. Well, the opposite, we remember, is just what is the same exact distance across the equal sign. So if I go across to the same distance on the other side, the opposite of -3 is a +3. And the opposite of 5 would be going across the same distance from 0 to 5. I want to go the same distance on the opposite side, so -5. So the opposite of -3 is +3, and the opposite of +5 is -5. Now let's see what happens if we work with a variable expression. Suppose I want to find or evaluate 15 minus the absolute value of x, but I have to be told what x is, remember. X equals -3. So that means the first step then I have to write out my formula or write out my equation, or excuse me, write out my expression. So 15 minus, instead of putting x inside the absolute value symbols this time, I'm going to put -3. So that's 15 minus, well, -3, the absolute value of -3 is a +3. And so 15 take away 3 is 12. And one last example, I promise, the last one. Evaluate the absolute value of a minus c if a equals 3 and c equals -6. So I have absolute value. Instead of a, I'm going to write 3 minus, and instead of c, I'm going to write -6. So we don't actually do this in algebra or math even, where we write minus minus. Whenever it's written this way, we put it in parentheses just so we can make sure that we didn't make a mistake and make an equal sign that went like that. Maybe our pen bounced or something. And so we use parentheses to make it really clear what we're talking about. So let's look. Order of operations says work with the parentheses first. Well, this is the opposite of 6, but I want the opposite of the opposite of 6. Or if I put it on the number line, I could say if -6 is here, the opposite of -6 equals a +6. So if I fill that into my formula, my expression, I have 3. The opposite of -6 is +6. Well, the absolute value then of 3 plus 6 is 9. And the absolute value of 9, how many steps did I have to take to go from 0 to 9? I had to take 9 steps.